Hey, welcome to Project Geospatial. This is Late Night Geo, and I'm Adam Simmons, and we have two guests on tonight, Jeffrey Pearson and Courtney Miller. So how's it going? Welcome, both of you.
Thanks.
Yeah, doing good.
You arrived just in time, Courtney. Pre-show, we had Jeff and I talking. So you two have not met. Courtney, go ahead and both of you introduce yourselves, and we'll introduce you to the audience as well.
Go ahead, Courtney.
I'm Courtney Miller. I am a senior consultant with Vector Communications. I live in St. Louis, Missouri, and pretty active in geospatial kind of, I would say, advocacy in the St. Louis area. So trying to get the word out about what's going on with geospatial, help educate the community about geospatial topics, and just try to get people excited about what's going on with the upcoming growth of geospatial and NGA West.
Cool. Yeah. No. I know there's a big NGA presence out there in St. Louis, so I wouldn't be surprised if it's a little bit easier to get marketing out, just because I'm sure everyone and their mom knows someone that's working for the NGA. But my name is Jeff Pearson. Right now, I am currently a solution engineer for Esri, which I'm happy to announce that I'm actually starting a new job on the 22nd with Collier's Engineering and Design, which I'm really excited to lead some of their GIS practices. So happy to announce that here on the show.
Jeff here is moving on to a new company, so we got an announcement on Late Night Geo. If those of you are watching, and we do have a couple audience members according to the metrics here. So good,
cool.
Awesome. No, thank you for both of you coming on. Late Night Geo is usually when try to invite random guests on. It's not so random because you two have been on before. So, but I always usually try to put the invite out there for anybody on the Twitterverse to come on and check us out, talk about anything on the geospatial topics, trends, or just talk about the general experience they have. And both of you have experience in that. And I know, Courtney, you've dived into the last year and a half, so you're getting your getting your feet wet pretty good.
As much as you can, not actually being in the geospatial industry. Yeah.
Yeah, and then of course, Jeff, you've been into it for quite a while now. So, and your experience is quite broad.
Yeah, no, it's I'm really excited to hear Courtney's kind of background with it. I'm really interested in hearing how geospatial people are utilizing the technology for business cases or marketing or whatever, and kind of, because there's a lot of tools out there that could probably help, but you just don't know what you don't know, right? So I think it's cool that you're on the show for sure.
Excited to be here.
Well, let's get started with a couple things. I like to bring up topics and trends and see what the reactions are for both of you coming up. So one of the most interesting things, I'm going to see if I can show the screen share here on the right. Let me pop that up and see how it pops up on the screen. Oh, and I got to change the overlay graphics here. It's a little bit weird. There we go. So I have the screen share here popped up. One of the things I want to kind of showcase is this really awesome, cool tech called the reality capture photogrammetry by Cesium. So they're actually working with Unreal Engine to come up with some realistic capture. So using satellite imagery and indoor imagery as well, photogrammetry to create these interesting 3D models for real buildings. So here's the actual 3-dimensional building within the Cesium. The Cesium engine or Unreal Engine, sorry. And you can kind of see how it is. And this is the actual some of the real pictures at the bottom they use to generate that particular 3D model. So pretty impressive stuff. And so it takes it to a new level when we can create more accurate 3D environments. And so you would think, well, it's like, well, real estate, what would you use this for? Well, the gaming industry is trying to make more accurate representations of the real life right now, but it's not just about the gaming industry. This is also about accurate simulations for either training individuals, pilots or first responders, or even the military of these different solutions as well. So what do you think about that, Jeff?
I'm interested in data collection. How are they collecting the data? How are they hosting it? And then how are they serving it up, right? If you are actually using this in real time with some type of, GIS, what what would the latency look like, right? How many cores do you have to host this on, right? What would you know what I mean? Like, I think it's super cool, obviously, but I would like to see a more in-depth real life demo, right, to see how it works. If I wanted to do this for my house, what does that process look like end to end, right? Do they need my CAD files? Are they using AutoCAD? Do they just take one of those cameras that you see the real estate agents go around so they can do the 3D kind of walkthroughs? Like, I'm really interested in knowing the kind of data schema behind that whole thing, right? That's kind of the first thing off the top of my head. But there's a lot of applications that you can do that for, right? Just, it doesn't have to be houses, right? It could be a whole bunch of other stuff, right? I mean, I see a lot of,
and they're advertising this as a free and open source visualization plugin starting available March 30th, 2021. So end of this month, that'll be interesting to check out, as well as offering the first full-scale higher accuracy WGS84 globe for Unreal Engine. And that'll be huge as well. So a global high accurate 3D model of the globe. I'm not sure how extensive that is, but that sounds very compelling for a lot of different aspects. Think about doing even machine learning on simulated data, for example. So
definitely going to keep my eye on that one. If that's open source, would love to dive in and even take a look under the hood for that, for sure.
Yeah. What do you think, Courtney? Any initial thoughts?
Well, I may have missed it too, but how do you capture, similar to what Jeff was saying, how do you actually do the initial capture? Because I think
so a combination of things, right? For the imagery aspect, they'll either take satellite images, most likely aerial, to grab the captures of these buildings. Sometimes they even take drones to take some of those 360 photos. I can guarantee you a lot of this stuff from the side are definitely taken either by drones. But photogrammetry is interesting, as you can take photos even with your phone. And those photos will actually there's probably a 360 photo, and that one's probably a drone going up, perhaps, or a long scaffolding to go up and take an image. We have another visitor there on the background.
He didn't fall asleep quite in time in Central Time here, so he gets to kind of hang out and be a junior geospatial enthusiast.
Yeah, there we go. Start them young.
Start them young, exactly.
But they'll use a bunch of photos to process this stuff, and it could be ground photos to mesh this together. And the crowdsourcing of photos for individual buildings. I actually saw a test of this 10 years ago out of the Smithsonian. This similar technology, just using, download an app, take a bunch of pictures, and we'll try to produce a 3D model of the building that you just took a picture of. And it's more of generates a point map similar to LiDAR of the building itself, and it's pretty cool. Of just generic photos.
So I'm wondering if you can do spatial analysis with this, right? I don't know, say you had a big building, much bigger than this, and you have a janitorial staff, and you want to see how many square feet, X janitor or custodian has to clean based on. I mean, if you look at the Pentagon or something, it's a huge building. Can you actually run data analytics through this software? Right. It looks visually, right? But how can you actually find a practical application where you can actually get some statistics out of it?
Oh, absolutely. Yeah, that would be amazing. And once again, I can't wait to see this used. Can't wait to check out the API, what the open source data really is, and what the scale of this really is. So high hopes potential. Maybe down the road, we'll get somebody from Cesium on to talk about this, or maybe even Unreal. So
we definitely do a follow-up, because if this is going to be open source, I can definitely dig in and take a look under the hood and really see what this thing could do, and then tell all the followers that yay or nay, right? Shout out to Cesium. It looked really cool.
Not to give a plug, but I am drinking out of a Borderlands mug right now, which I believe this is also built on the Unreal Engine too, if I'm not mistaken. So
very cool. Very cool.
Yeah, I think kind of similar to what Jeff said. I think really it comes down to how on the user end, how useful is it actually? Once you remove it from the company and the folks who on the technical side are able to operate it, how can you utilize it on the user end for whether it's director of operations, layers upon layers down the way that actually need to use that data. To me, that's a big part of what makes it, whether or not this is something really neat or whether or not this is something that's actually transformational in terms of really really able to change how we operate in terms of understanding spaces. Because otherwise, it's great.
Yeah, it looks really cool. It looks really cool, but like all those edges and the texture and all that stuff, are those actual vertices, right? Or are they just images, right? I don't know. It's kind of what
there's a lot of unknowns. I've seen a lot based off of LiDAR data, but I'm truly don't know enough about this particular service to know if what this is built on top of. So, and if you're able to do accurate measurements, or is it just a 3D model at the end of the day that you're integrating in with whatever? So,
cool.
So with that said, that's an awesome service. We got a lot of topics. So the next one, this might be not as we'll see it. So billions of cicadas will be emerging in the United States this year. So
not as sexy as the last one. Definitely not as sexy as the story.
Look at these little guys.
This is exciting stuff for me, though. Not just because because I live in an area that has a very strong cicada presence, and it's a pretty big deal once the 17-year cicadas come out. So I don't know where we fall in the cluster, but
well, I've been wondering when the big one is because it's been a while, and I think this is it. This is the big one, right? This is the big. Everybody's going to see them everywhere. I said that last year, and I was wrong. So the last brood, I was completely off on, but 3,000 to 4,000 species of cicada around the world, but 13 to 17-year periodic cicadas of the eastern United States are unique, and they just all come out at once. And I remember when this happened in Virginia, and it was everywhere. There were people having cicada parties, boiling them, eating them, soups. It was crazy. And if you've never experienced it before in your life, it is like, what is going on? It's like the plague around here. It's nuts. So,
where do you live at, Jeff? Do you live in where you have a lot of cicadas or locusts or summer bugs, basically?
I live in just south of Denver, Colorado. So
okay.
I don't think we have a large cicada. I could be wrong. I'm not a bug guy, or what are those bug people called? Entomologists? I don't know. Yeah. I'm not a big bug guy. So
you can kind of see I'm in the orange variety here.
Okay.
Zoom in.
So I'm trying to figure out the level 10 here. So it's this color legend. We talk about geospatial here, and this map is not great because I can barely tell what the color is of that dot. So I think it's a purple. So all the purples. Oh man, I think you're gonna get swarmed this year, Courtney.
Well, we might get them traveling.
Well, it's either brood. That's either brood 4 or brood 10. So brood 10 might be the circles. Oh, that is me. I think that is me. I'm over here in DC. I think we're going to
was made by UConn. Can we get someone with the freaking cartography department at UConn, please? Let's just walk through some cartographic principles.
You know what's even more embarrassing is geographyrealm.com is the one that's publishing this year. I'm like, come on, man. Couldn't you at least be so embarrassed about the map? Make one yourself. So.
What the around St. Louis area? What are those little triangles? Is that what that is?
They're right around here.
Yeah. What is that orange?
Brood 14.
Okay, so
no, brood 19. Sorry, I got it wrong. Brood 19.
Brood 19. I assume that means I'm not going to get slammed with cicadas this year.
No, we're on brood 10.
Okay.
Yeah, so we're on brood 10. That means it's going to be maybe Indiana, parts of eastern Indiana and Ohio, as well as Northern Virginia, Pennsylvania, and Maryland.
So anybody planning summer vacation who wants to feel what it's like to live in a horror movie, then this map is for you.
Oh, here we go. Here's something from the audience. Oh, look, we got a comment right here. That is a throw up map.
That is you could tell that some undergrad made this map because you don't granted, I did get a B- in my cartography class. Shout out to Jen Mapes at Kent State for giving me this. I worked hard for that, and I know enough to know that there's a lot of map crap.
Oh man,
in this,
University of Connecticut map. Here, I think contributed to the map.
Yeah,
of course, that's UConn. That's the UConn.
Let's.
Right? Oh, here's the data. Well, at least a loose database.
Okay, there you go.
It's not that great. I mean, we got to really dig into this, but it's like hunt them down, bring them on the show right now. Make a new map right in front of us.
Man.
Let's see. Anyway,
Well,
if cicadas, check them out. I'm sure there are better maps out there. This is just the article I brought up right away, and it caught my eye. I'm like, oh, this is news. We're going to be hitting this. I want to say, even though this is the year for it, I don't know exactly when this year they're going to be coming out, so I have to do more research on that.
I believe it's usually in late summer.
Yay. So next one, I think this was an article that you passed me, Courtney. So you want to talk about this one real quick?
Yeah, I think this one kind of plays along what Jeff mentioned earlier in the show about the application of geospatial GIS data and what it comes down to the application. So I think what I thought was so interesting about this is obviously we're doing a great job of starting to understand how important the application of being able to track people, viruses, all kinds of different layers of how things and people and their behaviors move in space, whether it's vaccine logistics and the spread of the virus, et cetera, et cetera. But I think one, I just love the topic of medical geography, which is an awesome topic in general. But I think what was interesting here is that, they're coming up with new and different ways to kind of take this information to track where and how the variants of the COVID virus have moved across the world, and really being able to, look, there's GeoCat behind me. We're getting the whole family involved here. Trying to see how that kind of moves across the globe. But what's really interesting to me is that they mention in here, how do we kind of get this information into the hands of those who can utilize it? And I work a lot with public health departments, and public health departments are set up according to census data. They're essentially assuming that they sit in their homes, right? It's based on population data. And of course, if you look back to the bubonic plague, the Black Plague, it spread most commonly across the Silk Road and the trade routes, right? So it was really about movement than it is about population. And to me, that is a big lesson learned about COVID, is that I'm sure when we come back and we really track its spread and see with the populations, it will certainly be population densities, but it's going to be more about movement. And so the concept of medical geography is going to be a lot about behavior, more so than just population. And right now, so much of public health is based around population demographics and less about movement and behavior. And I think that's what the key is, how do we find ways to get this information into the hands of public health departments and other entities that need it in order to deploy public health interventions? Because I know work. Go ahead, Jeff.
Yeah, no, I was just going to say, one thing that I definitely learned, because I worked for the biggest, mapping conglomerate on the planet, and I was highly involved with mapping the spread of the coronavirus over the summer. And so my graduate degree is in GIS from Kent State with an emphasis in health GIS, right? So all of a sudden, in March of 2020, I became relevant, essentially, right? Which I think was
you were always relevant, just nobody knew it until we were all sick.
Right. So one of the biggest things that I can say about being in the medical health geography is there is so much red tape on everything because of HIPAA law. One of the bigger projects that I did was there was an instance, I think somewhere in Northern California, where people were getting all kinds of crazy cancers because of this, random lake that was used as a some type of incinerator. There's arsenic and all kinds of stuff in the soil. People were coming up with all kinds of crazy types of these types of cancers, and they all lived within the same neighborhood, but no one was able to actually string that together because of the actual HIPAA laws, right? It's no one's hey, because they would all go to all
their
these
own
separate
individual
cancer
doctors.
centers or whatever, and they're hey, so it's that's the biggest thing. And then with the coronavirus, kind of the same thing, right? Just getting your hands on data that you can actually use to actually plot. I'm not a doctor, right? Like, they're not just going to give you the data. I don't work for a public health department, but, you know, I definitely consider myself a subject matter expert, but they just don't want to share any of the data. So it's basically like trying to help everyone with your hands tied behind your back, right? Granted, I was eventually granted data through a few public health departments and the Centers for the Disease Control, and we got stuff done, like where we were mapping out ventilators and, you know, which hospitals are overutilized and whatnot, because they wanted to,
which is such a weird backwards way to track.
Exactly, right? So,
and it's inaccurate because people, you know, they congregate around hospitals. That doesn't mean necessarily that's how it spreads. You know, people will travel to hospitals depending on the the area. Yeah, that's really interesting.
Like we were always kind of at least 30 to 60 days behind when it comes to tracking the spread throughout the whole summer, just because there was that data bottleneck, right? So I don't know if anyone listening has you know, any connections to Congress or whatever, but give the medical geographers the data they need. Come on, guys. So
yeah, let's not even talk about the whole Florida incident that happened earlier this year, last year.
What was the Florida incident?
Oh man, what was that? That was and I can't remember the exact details. It has to do with like maybe I think the person making the maps was told to report inaccurate numbers around the coronavirus spread.
Yeah, and she quit. She quit, and then she created her own dashboard and put it on Twitter. I still follow her. I can't remember her name, but shout out for sure.
Dang. Good story. Maybe we can grab her too. So,
yeah.
That'd be good.
Yeah, I think a lot of it will come down to the notion of is, you know, privacy versus results, and you know, people feel connected to. Okay, bud. Oh, we have a cup down in the living room.
Oh boy,
cup down. But I think is trying to figure out, like, there's an illusion of privacy that comes with HIPAA laws that people are still very much akin to, and the question is, can we let some of that guard down in order to be better at public health? And because right now it's a lot of ready, shoot, aim when it comes to a lot of public health reactions, although they're working incredibly hard and very dedicated individuals who are on the ground doing it. But you're right, if you can't take the best of the tools and innovations that exist out there and apply them to, you know, to what we're doing, we're going to run into this issue again and again. I mean, because we should have been able to go, if it lands here in some of our major, like, sort of port cities first, we should have been able to, you know, watch it spread based on transportation patterns, right? Like, people are predictable, right? I mean, that's part of the deal. And the fact is, we should have had a pretty good idea of where it was going in the first place. But I think because of the taboo of actually recognizing that people are predictable and that we can track some of their health behaviors and things like that, I think, and the political aspects of that, a lot of that was really slowed down.
Absolutely. Yeah. So I'm going to move on to the next topic here real quick. And that is, as I move on to a screen share again, let's see, as I'm getting better at these graphic switches in this new interface. Let's see.
Good job.
Yeah, working. You know, for those of you who don't watch the show enough, let me tell you, I have 3 or 4 different studios. A couple of them virtual studios up in the cloud, a couple of the studios on my desktop, and I switch between all of them because all of them have these updates and little nuances that work best with what. So if anybody wants to, I need to write some kind of massive blog post. Like, look, if you're trying to get into either podcasting, videography, here's my rundown of what to use, why you use it in these circumstances, because there's no one size fits all for podcasting and streaming. I'd say it's always, they all have their bad parts, and I always like to bring on guests. And when you bring on people, it becomes a whole different ballgame of what software you use. So with that said, why am I showing Umbra Labs? So my announcement, as we're jumping topics here, is this article claims they hit the regulatory jackpot. And by the way, this is an Umbra Lab article, so interesting marketing there for them. But on the other hand, they're working to put up their new star constellation, and apparently they just got permission from the FCC for 1200 megahertz bandwidth. You know, I guess that's going to allow them to generate images as low as, or should I say high resolution as 6 inches, or that's 15 centimeters or 0.15 meters. That's pretty impressive for radar imagery. 0.15 meter radar imagery.
That sounds illegal, to be honest. Like, I mean, I would be concerned, right? If they can get to that res through a satellite, I mean,
well, you have to understand. So NOAA, because they're the ones that really handled the licensing, and actually, it's later in this. It says here that they have a permit to shoot 10-inch ground resolution for their images. So that's not quite 6 inches. So there might be a situation where they're going to be capable of shooting a 6-inch image, but they're going to probably be able to legally release 10-inch imagery. So you have to understand that perhaps this is a lot similar to we'll call it Digital Globe / GeoEye situation back in the day, where they were actually capable of shooting like 1/4 meter imagery with their satellites, but at the time they were only legally able to sell the 1/2 meter imagery.
Yeah, isn't there? I think they mentioned that in the Geospatial Data Act that they just passed, right? Like, would they pass that like a year ago? I mean, it's the same reason why you can't go on Google Earth and just zoom in and, you know, see people's credit card. You know, if you happen to have your credit card out, right, and the satellite's going over, it's just obviously kind of a ridiculous kind of workflow. But I mean,
we also have to look at the type of sensor, and I'm sure that comes into play right here too, right? What is SAR capable of seeing, and what is it not? You know, yes, they advertise in the article that, now we can potentially detect objects as small as a soda can. Yeah, well, that's sure, but it's still SAR. It's a very complex data set. And just because you can detect an object as small as a soda can doesn't mean you can identify what that actual object is, because it's a SAR sensor.
Gotcha.
SAR is it's not an electro-optical. It's not, and for those of you who don't know, it's electro-optical means similar to, electro-optical is a passive sensor. It's like your camera. It's like your camera phone. You take an image and it comes in, the light comes in, and that's how it produces the image, right? SAR is an active sensor. It emits energy and it uses the radio waves and it bounces off objects, and the measurement of that energy is what creates the image. However, so actually determining what those objects are, you have to do a lot of other things to figure that out, and a lot of other analytics, a lot of other math, data science, etc., to really identify that stuff. And in a lot of ways, SAR actually had a lot of use cases because it's all weather, and it can be shot at nighttime as well. Unlike EO, which you can shoot something at night, but no guarantee you're going to see anything except for night lights, right? So we have to keep the sensor in mind and what it actually is capable of seeing. Just because it has really nice resolution, what is it going to reveal about somebody or people or human activity, right?
Well, thanks for helping me back off that ledge there. I'm admittedly not an imagery guy. I know about imagery, right? But I'm definitely not an imagery expert. So I'm just thinking, wow, man, that's super high res for, you know.
Oh yeah. But keep in mind, I think I have to go back to the NOAA license. I should have this memorized by now, but I know a lot of the providers are releasing openly 1/4 meter imagery. I think the license allows, the open commercial license now allows everybody to go down to the EO folks to go down to 0.15 meters. And maybe as we're talking about the next topic, I'll bring an example image up to show you what that actually looks like, because it's not as good as people are thinking. You still can't quite see, you know, you're not going to be able to read a license plate yet. I mean, that's pretty close, but it's not as close as people think it is. It's really nice imagery, but you know, to be able to identify somebody actual from a face, you can't do that yet.
I mean, how far out are we though? Because I barely pay attention to this, and I still feel like it's a race to that point, like soon. Because I keep seeing, you know, press releases and stuff that it keeps getting lower and lower.
Let's remove the satellites out of the picture. You have drones and aerial imagery in the mix as well. And from that standpoint, yes, very much so. The resolution of the images is not just how good the camera is, but how low in altitude they fly. And so And you can kind of get examples of that when folks post drone imagery around. And if you want to get an example, even off the news, when they show some of the military drones that are overseas, how close they can really get. You can literally identify people. It's so if you don't just count satellite imagery right now from aerial photography and drones, it's pretty powerful stuff, and the sky is the limit. But in terms of satellite imagery, we still have some ways to go. And I think eventually it's not going to be about how close you can get, but I think the satellite industry cares more about persistence right now. So how often can you collect during the day to actually measure relevant activity? So, the once a day collect, what kind of activity can you really feasibly collect to get a sense of activity? Well, it's not enough to get traffic patterns per se, at least from a day during the day, but it is enough to get traffic patterns over maybe a course of maybe density over day by day. I mean, there's some use cases you can get out of it. Especially if you take those shots at certain times a day, right? But the closer you get in frequency, the more human activity you can measure.
Yeah, then it's less about just stagnant and it's about behavior.
Yeah.
Which again is I think what everyone is really, ultimately is interested in.
So let's see. We're going to move on to another topic, and I'm going to point it to one of. Unless do you have anything to bring up, Jeff?
I was going to say, with like the drones and the planes and stuff, like just look at the the SR-71 Blackbird and the U-2 and, kind of all those military assets that's what they do, right? I mean, those planes could fly super high and they can get pretty close to kind of what we're talking about. But that's for like all the defense stuff and whatnot. And you have military
I have an archive folder. I think I can probably bring up an example of an SR-71 photo, or even a U-2 photo from the 1960s or 70s. I got from the.
I don't want to go to jail, Adam. If it's top secret, I don't want to see it.
This is from like the Library of Congress. You can dig up.
Oh, gotcha. Okay.
Right? So let's see. This isn't U-2, but give you an idea. Let's see if I can bring this up on the screen share.
I mean, because like what we're talking about is kind of what the NGA does. That's like their mission. Is they're looking at overseas, countries, and they're monitoring what's kind of going on spatially, right? So
yeah. So this right here is Sapphire, and I had to look up exactly what Sapphire is. Maybe a satellite back in the day, but this is not. I mean, it looks like really nice imagery from zoomed out, but this is a radar shot. But it's not. It's actually not that great when you zoom in. So that one's a radar shot. Let's see. Where is talk about a really nice radar shot? Whoops! I lost my screen share. I just need to share the entire screen.
No worries.
Yep, this is the U.S. Capitol shot in radar. I think this is a more recent shot by somebody. And for someone who doesn't, here's a U-2 image of the. This is a radar shot of the San Francisco Bay Bridge. So,
and how high up do you think they were when they collected this?
Oh, I could guess. I don't think. I mean, so publicly, we can. You know what? Because I want to keep legit for what's available on the. We can just do a quick. Why not just do a quick wiki search, right? Because
Gotcha. Yeah, it's. I know that it's super impressive technology, right? It's
70,000 feet according to a Google search.
That's insane, right?
70,000 feet, which I think what's the ceiling for getting into space? How high do you have to be to? I think it's like 90,000 feet, right, or 120,000.
Yeah. I think so. Yeah, I think the ISS is like, I think right there, like 120 or something.
100 kilometers. Okay, well that's a little bit higher than 100,000 feet. So 100 kilometers is 62 miles. So convert that into feet, and what is that? 327,360 feet. So a little bit of ways off. But if you see some of the videos of the U-2, They had that. I remember when I was in the Air Force and I was stationed at Beale Air Force Base. That's whoops, we had to go back to the upper thing. When I was stationed at Beale Air Force Base, I think they had a documentary crew come from to actually sit side saddle and do a documentary on the U-2. And I mean, the guy was the luckiest reporter in the world. He got to sit in the back seat of the U-2 and go up. And he may have only flown up like 70,000 feet. But I can tell you, it looks like almost, well, maybe not as high as my background here, but it does look like you're in orbit.
In space, insane. Yeah.
And I'm like, you know what? Yeah, and it's incredible.
Yeah,
and you wear pretty much spacesuits, so. Yeah,
no, they absolutely do. I think it's important to note that, so it's like, why are they even putting any R&D into the satellites? Like, I know that they just did a whole bunch of imagery and rovers and stuff on Mars, right? I mean, you can't just fly a U-2 or a plane around Mars, right? So, because obviously you have to land there. So like all these satellite R&D tech, like they're collecting really great imagery of Mars right now. So
yeah, and we can show it again at some point, but we had not just great imagery, but and that's something Esri actually came out with, was a map of Mars, interactive map of Mars, a 3D globe of it. You know, I know Google Earth had a 3D map of Mars, but the Esri one is updated by the Perseverance imagery that when they landed, it shot some images on the way down, and that 3D globe that Esri came out with is updated with that images as well. So it's pretty cool stuff.
Yeah.
So next one we got on the list for articles here. I think this is another Courtney submission, right?
No, I think there's I do not think so.
Oh, no. This is nothing related to that. Here we go. Women in GIS, shutting down stereotypes in GIS. So talk about this one, Courtney.
Yeah, I just thought this was a really great story. It was from Maria Hochleitner, who sort of talked about how her kind of evolution from starting in more of a marketing side of things and eventually getting really interested in GIS and geospatial, but also how she sort of felt out of place and still feels a little out of place when it comes to feeling when she's giving presentations or feeling like she knows what she's talking about. And I think it's a very common theme for a lot of women in STEM fields, but I mean, a lot of fields in general is feeling like that they can own the space that they know about, that they're very familiar with the technology and feel comfortable talking about it in front of an audience, not as, any sort of token type of presentation, but as a subject matter expert. And I thought that she had a really interesting voice because you could tell she was very passionate about sort of speaking from her own experience, just saying like, I know I'm allowed to be up here. I know that I'm completely qualified to come up here and talk about this, but I just still feel like I'm not. And I still look out into the audience and feel or see the sort of looks of like, does she know what she's talking about? And I think that as we're, obviously I'm outside of the industry. And so coming from a different perspective, but for when you're looking at sort of the next generation of how we continue to build out this innovation and build out this technology, and we talk about this a lot in St. Louis, is how do you get, women, people of color, folks who are typically non-military, who are outside a lot of times of the sphere of what's going on with geospatial. How do you get them interested and realize that it's approachable and that they have a place to be able to participate? I mean, even the concept of GIS, I think a lot of times seems like, was that like coding? I think people get kind of a wrong idea about what it means in general. So, I mean, part of what we're trying to do in St. Louis is how do you demystify geospatial so that people like myself can talk about it and understand it and get excited about its commercial and governmental applications. But also, how do you invite people into these spaces and make them feel welcome? And I think that's, a lot of that is making space for, moms, or just, being able to like allow people to transition basically into learning more about this technology and applying it. And so I really appreciated her story. And I think that, more and more, and in St. Louis, we have a geospatial accelerator And I would say at least half of the people who companies are there are actually run by women, many of them women of color. And I see some ways in which they may actually kind of downplay that as a means to make sure that they're taken seriously. And, so it's worth an ongoing conversation, I think, especially as the next generation comes up and gets interested in the industry.
Well, absolutely. And I'm going to pipe in real quick because it relates to a tweet that right before the show started, I had a chance to put out there by Sabrina Cito. She's part of the Women in Geospatial group. And what's fascinating is, she posted out more of a giant request out to the community. And the request was part of the GeoConnect Asia conference coming up. I believe it's at the end of this month. They have a number of speakers, and there's been I think only a third of them are women. And she's trying to reach out to as many groups as possible to get more, we'll call it gender background representations from Asia Pacific, China, etc., to be a part of this and grow the representation in the geospatial community within that region. So that just went out. So there's a big effort still. And I encourage you, if you don't know anything about the Women in Geospatial group, they're an amazing group that stood up not too long ago in the recent year or two. They've been in stride. So.
That's right, bud.
Yeah, look at that. We got some add-ons by Junior Geo there.
I think you just got an eye roll there.
Eye roll. Nice. Yep. So good on it. And we at Project Geospatial also try to support any way we can. So we'll reach out to folks for this and see if there's any way at least we can get the word out for because they're still opening up solicitations for some talks and for participation in this particular event. So look out for that. Let's see, what else do we have on the plate? And while I'm looking at that, let me switch over to the three of us again. So
sure.
Let's see there.
So if possible, I'd like to kind of pick Courtney's brain a little bit about how you said that you're in marketing and business and kind of all that, but your background isn't in mapping or your geospatial, right?
Psychology.
So that's awesome. So how did you kind of find out about GIS and spatial statistics and all that stuff? Like, what was kind of that aha moment where you're like, hey, this is actually valuable?
Well, I attended GeoInt 2019 because St. Louis brought a big delegation of about 40 people to San Antonio we brought like basically a mini visitor center and to show people about what was going on in St. Louis and geospatial, because NGA is building the new NGA West campus out there. It's like a $1.7 billion new investment out. And they're going to be growing their workforce by a large number of people. They're declassifying and semi-declassifying 40% of the space within NGA West in order to allow more, innovation and commercial interaction and things like that. So we knew like there was a good potential to really build up the kind of commercial and civic and defense subcontractor kind of industry within it. So I attended, and I honestly, I didn't know anything really about, do you want to get down? I didn't really know anything about the industry in general. I mean, I went in pretty green about it and started getting more involved in that way and, made friends, started talking with folks about what was going on and kind of just started to see myself what were the applications and how it was interesting. The work that I do is in public engagement. So I do a lot of communications and public engagement and stakeholder engagement. So I'm sort of naturally aligned to tracking how people behave and how they interact with the world and the community and how they interact with each other. And so I see like a pretty natural, it's like a parallel kind of thing. Like the concept of human geography, a lot of what I do is based around basically like the on the ground applications of human geography, only using, ideas and messaging and things like that. And so that's why I've kind of gotten more into it. And then as we're trying to build out and talk about it, it's interesting. You can see the applications of it. You can kind of see how how maps would enable you to be better at public health and better at real estate planning. And I do a lot of economic development and community development, all of which is very much, the more you understand trends and how people interact with space and behavior, then you can be better at doing these things, rather than just necessarily, making big plans and not really understanding how it works. So to me, there's a really natural application, and I'd like to see more of it happen now that we are building up our industry of geospatial so much in St. Louis. We have a big Esri presence. We have a big Maxar and presence. Is how do we take that and really bring the industry into the community and say, hey, can you help us with our government decisions? Can you help us with our public health decisions? Can you help us with education? Because those are real-time problems we deal with in our community, and I'd like to see it, actually get some cross industry conversation so that we can actually use these innovations into making our lives better.
Absolutely.
Plus, it's cool. No, it's cool, Jeff. It's cool. This is cool. Dirty cool stuff.
Cool. Absolutely.
And it's fun to share with like my kids and stuff. Right, bud?
Well, let's take a quick break. I want to show people what 3-inch imagery looks like. And 3-inch imagery is the equivalent of 0.0762 centimeters. So let's see what that looks like. So for those of you asked last time, how close can you get with, well, this is 3-inch. I've actually seen 1.5-inch too, which is just half of that too. So this is a sample of aerial imagery that's over Ohio. And this is freely available, by the way, on the Ohio Imagery. You can look up the Ohio Imagery program or whatever, and the state of Ohio releases this. So if I zoom in here, and yes, I'm using ArcGIS in the background here. So let's see, it's getting closer, tallying up. This is how can we get to these cars when it just tiles up, depixelates a little bit. So give it a little space, but this is as close as you can get without it looking too fuzzy. Okay, we can kind of get a little closer. But this is a 0.0762 centimeter imagery, 0.0762 meters. I'm sorry, it's 762 centimeters, 0.07 meters. I'm always used to hearing things in meters, so converting things back and forth. But this is how close you can really get with aerial, at least with 3 inches. And like I said, I've seen a 1.5 inch. I wonder if I have an example of that over here too. I do. I think I can load that one up.
So this right here is 3-inch imagery, you said?
Yes, this is 3-inch imagery.
Okay.
And if I open it up, where happened to my what did I do with my bar? I closed up all the tabs. Now I'm going to bring it back. Let me just drag and drop. This I'm loading up is an example of half of that. So this is apparently a 1.5-inch image. And you can see it gets a little bit better. But not much. Not much better. And I believe the contract for this imagery for Ohio was done by Wolpert. So they do a lot of aerial collection. And I think they were contracted to do that over the state of Ohio. And they were collecting every county. And I think that's still going on. But you can download the entire state as imagery. And it's at those different resolutions. So really great test bed if you want to check out aerial imagery. But satellite imagery cannot get down to 0.07 meters. I mean, get down to 0.1 some cases, or 0.15, but not 0.07. So this is pretty good. This is pretty good stuff. You can do a lot here. There's a cell tower right there. So man, I can just start picking things out here left and right. It's nuts. Yeah, this is where I get lost. I was like, this is how cool this is. I mean, I can get lost in this for I can get lost for a little bit, just checking out how good this is, what else I can see. I mean, I see imagery a lot, but just to see stuff like this gorgeous, and this, and of course, over the massive area. So this is Hamilton County. This is covering Cincinnati, Ohio. So it might be a familiar spot, not too far from Courtney over there. So
only 5 hours.
No, only 5 hours.
So when you pull this in, is it already pre-georeferenced, or do you have to?
So, it is orthorectified imagery. However, it is it comes in Mr. SID format. So if everybody wants to know how big an entire county is, this entire county was, let's see, the zip file for it. Well, I don't have that. I can't find the zip file for Hamilton specifically, but I do have the zip file for Greene County or Montgomery County. So the zip file for it's 41 gigs, but the actual image for this, when you unzip it, it's only 10 gigs for Hamilton. But I guarantee you, if you convert this in a GeoTIFF, that's the problem. Mr. SID is like super compressed. Is like, so a Mr. SID file, when you change it over to like a GeoTIFF format for this big of an area, that all of a sudden blows up to this one, probably around 70 or 80 gigs. But some of the bigger counties, like that whole 30 or 40 gig county file, easily 300 or 400 gigs. Like they're the largest imagery files I've ever seen. I mean, these are massive mosaics though, but they're nuts, huge. I can barely load them up in the ARC as it is. So, I mean, you not only have to have good software, but you also have to mail the machine to handle that much memory and the graphics card, right? So these are massive images, huge. I mean, better to process this stuff in the cloud and visualize it than on my local machine. But hey, I got something that can handle it at home.
And that's why I'm a vector and an enterprise guy. That is 100% why I'm a vector guy.
A vector guy. So yeah. So you just deal with the points and polygons.
Points, lines, and polygons, baby. That's where
so
I like
what's
to
the
live.
what's the biggest point and polygon database you've messed with?
Oh God, there's trying to think. Probably out of the DOT right now, just their national roadways inventory, right? That's a pretty big data set. And then trying to convert that into a traceable network. That's I don't know, put a gig number on it. It's pretty big. It's probably like 20 or 30 gigs, I'd say. Yeah. And it takes forever to load up. So
folks, you won't be loading those big data sets into Google Earth anytime soon. So I don't know if anybody realizes it, but Google Earth can only handle around, if you're lucky, 50,000 polygons or points at once. I've gotten it up to higher than that. I get really lucky by having a lot of memory pushed through it. But it's really rare, and usually it crashes at about 50,000 points. So to be able to handle more than that, I like to take advantage of things like CartoDB and things like that. But obviously, ARC can handle impressive amounts of data either way.
Yeah,
but once you get in the gigabit range, it's huge.
Yeah, I tried pulling in the national wetlands inventory into Google Earth once as a KML. Yeah, you can only get like maybe not even a county. It's just super dense data, right? So
absolutely. And so for those who don't know, Google Earth pulls, or even Google Maps or Apple Maps, whatever, the satellite image on there, a lot of it during the major cities in the United States are actually based off of aerial, not just satellite imagery. But most of the satellite imagery that comes in for Google Earth now from Digital Globe or now Maxar, and that's all pushed through. I don't know if they have too many locations with the newer higher resolution images in there, but most of it's pushed through at 0.5 meter imagery. So it still looks pretty decent. And what's cool about me going back to Google Earth as opposed to these other things is freely available. I get a time series stack in there, and I like going back to the actual hard client because no other client right now allows you to go through a time series for freely available imagery just to kind of check out what's going on in the area. So
I think it'd be really amazing. Yeah, it'd be really amazing to be able to use that level of imagery to discuss things with the public too, because so much of what we use is like Google Maps, and it's just not concrete enough for people to really get things when you're talking about geographic. You're trying to get people to think about abstract geographic ideas, and they're just not getting it from Google Maps.
No, not at all. But with that said, how do you get, because of these government organizations, they all have their own GIS departments, and how do you get the state or their county to be convinced to even buy into the geospatial program to be able to collect imagery or contract out collection of imagery higher resolution enough? I mean, usually the guy, a lot of times these folks that are working on small budgets, or they have to basically win a cultural battle on on the usefulness of this information. Right?
Sounds like you need to have somebody from Ohio in here to give a case study. How did they manage to make it happen?
Yeah. Well, and there's a few cities and a few states that are good case studies on providing GIS data. I mean, YC is actually a really awesome geospatial department and release a lot of good geospatial data. Another ones I've seen in the area, even locally in my counties nearby, county by county, spreading out. They all have a lot of geospatial data as well, but we have a lot of government agencies within our counties that help, I think, support that effort too. Jeff, do you have any governments, local governments and things like that are pretty savvy on the geospatial realm?
Yeah, I work pretty closely with South Florida Water Management. There's a few, so I'm actually on the board of supervisors for the Douglas County Water and Soil Conservation here in the state of Colorado. And I kind of went in there, I'm kind of building up their GIS now, but the county, Douglas County, they have a really good GIS department, really bunch of super solid guys in there. And then down in Pompano Beach, Florida as well. I mean, just off the top of my head, like local government, I feel like, I don't say they struggle, but a lot of local governments struggle with that just because they don't have the big budgets and they can't hire a lot of the best people because they go to, big tech or they go elsewhere, right? So towns and local municipalities really kind of struggle with finding good people because they just can't pay them, right? So it's kind of tough.
Oh, absolutely. Yeah, no, that's great. And I know the big ones, even, I think what was fascinating, and maybe Courtney, as you showed me this or something about the real estate market in St. Louis on how you can use certain, or maybe I saw an article about this, how you can use certain of the real estate market to look back in time at certain neighborhoods because their streets and neighborhoods actually haven't been updated, right? From the polygons, the actual vector files in the background. So you can see where developments are, but see where the streets in old neighborhoods used to be, because on top of the real estate, the modern imagery, the polygons were not updated. So looking back in time from that perspective, you can see how communities either grow or where they used to be and where even the deprecation of communities are with the low income areas and where neighborhoods might need more help or what gentrification looks like. So how you doing over there, Courtney? Is he all set up with his race car? Oh, space shuttle. Nice.
It requires a lot of batteries, which I was not prepared for. So
that's awesome.
But in true working parent form, I am multitasking right now. So
another comment from the audience.
Yes. Joyo Geo understands. Like that guy's on my side tonight.
All right. So to bring up another let's see. Well, I'll wait till she comes back because this is her article again.
Cool. I really like the platform that you have here for this. It's a lot smoother than I think it ran the first time we did it back in March of last year. I can't remember.
I probably use, so I secret sauce, folks. If you get a chance to watch Late Night Geo, I'm willing to talk about stuff. So secret sauce behind the scenes. I use a couple different studios. One, Lightstream. I like Lightstream. It works really good because I have a lot of customization issue. So Lightstream it's Lightstream Studio. So there's you can look it up. You'll be able to find it. It has the ability to invite guests into the platform, and that's very unique as well. Not a lot of be able to do that, but as we'll call it director behind the scenes, I get to control the different frames and move the different camera scenes over to be able to account for people. So that's really nice. I like Lightstream. Bad part is it can be a little bit unstable from an internet bandwidth connection standpoint from the guests, etc. So that always makes it a little nervous. The other studio I like using, and for those of you who don't know, right now I'm using Restream.io. Restream.io has a very simple studio. So that's the downside of Restream. I can invite guests, allow to send me a guest link, but there's only so much I can do bringing in graphics. Now, with that said, they just enabled an RTMP link, which means I can actually use my broadcaster software on my desktop, which is OBS Studio or XSplit Broadcaster, which I like the most. The problem is there is some logistical complexity behind using those desktop studios at the same time, and that's where it gets a little tricky. So I like to keep it, sometimes when I'm in a bind, I like keeping it simple, stupid, and I'll use the studio itself on the web, and I'll just bring people in and keep it just like that. You know, there's something to be said to have these cool graphics and cool little apps and overlays to work on it, like a lot of the gaming streamers work. But when I need something to work fast, need to work simple, just start the stream up and just get going. And that's what I usually aim for. So that's about, I think I just mentioned 4 pieces of software there. And I think I got 2 other ones I'll use on the side, or I've been dabbling with. You know, one of them is like Live Stream Studio, which is out of Vimeo, which is a nightmare. So if you're like a professional broadcaster, that's what a lot of them use behind the scenes for like TV broadcasts. And that's like, I would call it overcomplicated. Significantly, like we're talking about more knobs and dials and figuring out what to do than most tools I've ever seen. And they really need to update their database or their UI. It's not meant for the simple broadcaster. Let's put it that way. So with that said, thanks for listening to on my broadcasting side, taking a deep breath of what happens behind the scenes. We're going to do 1 or 2 more articles and we're going to wrap up. One of the articles that I want to showcase here is another one of Courtney's, actually. Courtney, you want to talk about this one? This is about mass transit, which I think this is your realm, right?
Yes. In a previous life, before I started working, before I started working for where I did before. I know, but here, we're going to talk about transit. You want to talk about buses?
We're going to talk about transit.
You want to talk? Look at that. You want to look at that? Whoa. So previous to this, I actually worked for public transit, and one of the biggest.
My day.
No, I agree. But I think.
My day.
Yeah. Oh, can you go get it for me?
Yeah.
Okay. So one of the things that I worked from public transit specifically in communications, but one of the things I did was really look at a lot of the innovations in public transit. And one of the things that has always been on the horizon is autonomous vehicles. And one of the great usefulness of autonomous vehicles are actually in lower density areas. So where you've got a need for public transit because the population has need, there's employment centers, there's people that needs to get to jobs, but you don't have the density in order to invest in the infrastructure of light rail or even BRT. You don't run empty buses half the day. And what is probably going to be the most efficient and both cost effective and equitable source of public transit is going to be transit on demand, small autonomous vehicles that are able to basically, like I said, I've been moderately obsessed with this idea for years, but basically you're able to wear some sort of wearable that allows to track behaviors of folks who need transit, and then that coordinates with autonomous vehicles that can then meet the demand of people moving between like employment centers or major education centers, hospitals, things like that, so that you can actually provide the same sort of convenient on-demand transit that is expected in high-density areas in lower density areas such as like outer ring suburbs, employment centers. Sorry, guys, we're opening up a lunar launcher now. This is Plan C in terms of keeping him busy. And this article is talking about basically that there's several companies that are working together to now deploy these autonomous shuttles, which I think is really what's unique about this and interesting is a lot of times the conversation around public transit is buses as large vehicles, because obviously that makes sense, right? And they're doing this in France and Israel. But when it comes to a lot of I think the next gen of public transit, it's going to be smaller size vehicles like shuttles. So rather than something that is like, something as hardcore as a bus, I think the shuttles are actually a perfect way to get people comfortable with the concept of autonomous vehicles and transit on demand, while also serving areas where you have incredible need for equitable public transit, but you don't have the density for other things.
Awesome. No, that's and then from tracking all that, it's gonna. So this particular system, the looks like the what is it called here? I just read it. iCrystal shuttle. It looks like it's being deployed to France and Israel right now for testing on the roadways, and looks like ready technology designs for production by 2022. So just around the corner, those countries will be seeing this right on the ground. So, so from your perspective, Courtney, have you seen anything like this actually within the U.S. for cities? Or
I have not. Although arguably I have not like kept as track of it as I did once upon a time when I was working directly in public transit. I do know that we're starting to see some movement in Canada in terms of in North America. And interestingly, the way in which that is really coming about is based on imagery. So the way in which that they're really starting to build out the, not only the user case, but also the, okay, bud. But also the way in which to actually make these autonomous vehicles work is by using satellite imagery. So they're using that kind of what you're talking about before, Jeff, about and Adam, about being able to look at the frequency, like persistence of this imagery in order to create use things like traffic patterns. That's actually what they're starting to do in Eastern Canada in order to track traffic patterns to allow for the possibilities of autonomous vehicles in public transit. So they're not just using like on the ground kind of like GPS tracking, but also using satellite imagery to track traffic patterns and people movement patterns and things like that. So I think that there is a good case. I think it's going to, just like anything else, sometimes North America or the US is not the first to adapt some of these technologies and applications, especially around public transit. We're probably going to get it coming out of Europe and South America and places where in Asia where there's more demand for public transit and more of a cultural use for it. But I think this is where it's going right now. It's basically like a souped up Uber, right? Like being able to be, to be able to walk out of your job and rather than have to wait at a bus stop for 10 minutes and hope that a bus comes by, the bus will know you're coming before you even once you start leaving your desk kind of thing. And eventually would be able to track your regular habits to be able to know this looks like a regular movement. They're moving towards the main location of pickup. And so they'll start being able to predict your behavior and behavior of anyone else in your vicinity who's taking it as well. And these smaller size shuttles are really perfect for that. So I would love to see this deployed in a place like St. Louis where we don't have the high density to invest in public transit, the big expensive stuff. So fingers crossed that we get some of this really sexy public transit stuff starts making its way into the U.S.
Who had the last, I think a year and a half ago, I was visiting St. Louis. They had the big giant, who's got the tunnels, trying to do the, what is it? The underground.
Oh, Hyperloop.
Hyperloop. That's right. Yeah, they had a Hyperloop demonstration.
Eventually, actually, DC was the one that I'm pretty sure is getting their first test track is the DC.
Oh,
area.
Probably from Baltimore or New York to, I think it's probably Baltimore to DC.
Yeah. So you'll have to tell us how Hyperloop is.
I need to keep up to date with it. So, well, that said, go ahead, Jeff.
Sorry. Oh no, just a quick question on that autonomous kind of thing. Just coming from a capitalistic standpoint, how much does that system cost? And then how many people can that thing right? Because in Denver, I think we probably have 300,000 daily users for, public transport, right? With the buses and the trains. So is there an expectation to have 300,000 of these things driving around the city at all times? Or what's how does that scale, right?
Yeah, I'm not laughing at you, Jeff. I'm laughing at my son taking tools.
it's totally fine. Yeah.
Behind me, I can see him taking pointy things out. That's the whole reason why I think these kind of shuttles are so interesting, because the infrastructure, Hyperloop was something like $1 billion per. I don't know. It was $1 million per mile or something, not $1 billion. Something insanely expensive for most metropolitan areas. And arguably that there's already multiple ways in which you can get from places like DC to New York and things like that don't exist between like Kansas City and St. Louis, or Denver and I don't know what's Salt Lake or something like that. Yeah. Like where you've got a reasonable, you've got two nodes of good connected like business infrastructure, but there's no other than like a 5-hour drive or a kind of annoying plane ride. But things like autonomous vehicles are much lower infrastructure costs because they're not built infrastructure. They're technical infrastructure. And I mean, yes, they're the vehicles, but you don't have to invest in physical infrastructure, which is what makes public transit, that's the barrier to making it work in lower density areas, because the cost benefit ratio is so high.
Gotcha. So in a place like St. Louis, how many of those things would you need in order to make an impact on the public transportation infrastructure as it is?
I don't know. I mean, I think I would think of it more in terms of nodes than I would people at first. I would look at places where you have like employment centers where you have the demand for public transit, but you don't have enough demand for a larger infrastructure like a full-size bus. So I'd probably try to work to identify nodes. And that's something too that you can use with geography, because you can look in places where you have like a high density of commercial real estate, and maybe even like a high density of commercial real estate plus cars. That usually means that somewhere in there you've got people, and that also means there's probably people who can't afford to drive. So, you look at those two kind of things together and figure out, like shopping centers are a great area. There's people who work in those like restaurants and they clean the floors and things like that, but they don't have cars, but they need to go out there. You see that in suburban areas all the time. Like I don't know if you live in a suburban area, but you got a mall that's out pretty far. Everyone drives to it. Well, what happens about the people who need to like get there, who maybe lose access to a car for the day or whatever? To me, that's what you need to look at in terms of investing in your infrastructure, what meets that criteria. Because once you create a product that recognizes that demand, you will get the people to utilize it. I'm sure it's gonna be scary at first for all of us to be able to use use autonomous vehicles, but it's probably not any worse than riding a city bus. So
I think every time I think of autonomous vehicles, I'd be excited to try one out, but for some reason in my head, I still got Total Recall in my head with Johnny Cab or whatever it is, the nightmare that is. So
it's going to be interesting to see how culturally we figure out how to incorporate it into our lives, because it's going to happen regardless, but it'll be interesting to see how it happens. But yeah, that's how I would probably figure out the infrastructure need for it. But a place like Denver would actually be really good, because you guys have insane growth, but it's still very expensive to deploy things like light rail.
But didn't you have the weather, as Jeff was just talking about me right before the show, right? You got
that is true. I don't know how they work in snow.
You get these like massive time to get a lift on that.
You need to get like a autonomous Subaru.
37-inch tires on that little thing.
I think that's exciting stuff, though.
It is.
Well, I want to give each one of you a chance. Go one last round here. Jeff, do you have any last words, mentions, things that you want to talk about before we sign off today?
No, I appreciate being on the show again. This is number 3, and follow me on Twitter at GIS_dog. GIS_dog is my Twitter handle. So please shoot me a follow. And I definitely appreciate the chat, Courtney. I think those are really great articles that you brought to the table. And and I also I will dig into that. What was it called? Cesium. 3D building
Cesium.
Type thing.
Yep.
Yeah,
I believe
I will.
It was. Cesium. CESSIUM. Yep. Cesium.
Yeah, I'll definitely remember that, because that's my favorite element on the periodic table, and I think that was a really cool kind of like a video there. And I will dig in, and I will follow up with you, Adam, to kind of dig under the hood. I'll try to reverse engineer some of it to see what it's like.
I highly encourage you to check out the Cesium. They have an open platform API for checking out making basically your own globes with data on top of it. A lot of the satellite tracking for Cesium got built on top of that. So very cool potential. So let me see if I can.
Oh, it's actually JavaScript. I love it. It's JavaScript. So I'm already halfway there. So
I'm actually going to really showcase something of the potential in Cesium. It's going to kill my computer's memory when I do this, but here we go. Let me bring it up. These are all, and occasionally they do this too. Cesium does this. So there's variations of this. So let's see if I can bring this up. This is the globe, and these are all the satellites around the Earth right now. And you can actually, this is built off of their API. Somebody did this. So you can actually press the play button. There is a play button here, I swear. Oh, I have to increase the speed. They were moving live. So if I actually zoomed in there, you can actually, whoops, no, too close. You can actually see them moving right now. So this is kind of a live idea of the satellites moving in orbit.
Oh man, that is cool.
Now,
is there any kind of like weird, I mean, can you see them from any kind of like native imagery? Like, can you see this weird asteroid belt of satellites we have going on here?
Wow. There's a kind of a satellite or like a belt around here you can kind of see. So where they are. So we're actually creating our own little kind of Earth's belts, like, Saturn's rings or something like that. So we have our own little artificial belt going on. So cool thing. So for those of you who don't know, any guess what these are right here? I don't know if anybody keeps up with the news. And by the way, there's a series of them right here.
It's around China, right?
Well, they're moving, so they're all orbiting here.
My guess would be something to do with weather or seismic activity. I don't know.
Let's click on one and find out. And I know exactly what it is, but you see the Starlink. These are all the Starling satellites.
So I'm embarrassed to say that I don't know what that is.
Okay. A Starlink is the...
I didn't either.
Elon Musk has this project for creating satellite internet. So we'll have to see how many... Let's see how many Starlink satellites there are.
Oh, look at it moving.
Right now. So right now there are 1,200 Starlink satellites in orbit. So Elon Musk now owns a percentage, actually a huge percentage of the active satellites in orbit right now, which is actually pretty interesting. So talk about owning a certain capital of physical space up there in terms of he owns a significant part of it. So 1,200 Starlink satellites are up in orbit. So this is satellite internet, and not to put a plug out there or anything, but you can actually sign up for the beta of Starlink right now. You can actually get 150 megs, trying to get 150 megs downlink, and you can sign up for Starlink. I think it's like $100 a month for the beta. So, yeah, it's supposed to be global internet. That's what they're trying to test out. It's impressive. Yeah, so, but that's not what I wanted to show you this, Jeff, because this is the power of all you're a vector file guy, right? So these are all these vector points surrounding Earth, and you can increase the speed up here to see the satellites moving at speed. You can change the time frame here. Wow. You can open up the satellite catalog. So they have the spreadsheet here, and you can check on what's collected. You can usually have a quick little search database to look for a specific item. This is all out of the Cesium API.
Wow, interesting. Yeah, I'll definitely have to dig in on this for sure. Cesium.
Yeah, that's really interesting.
Just kind of a fun fact about Cesium, the element, and we're talking about Cesium, is that's how they actually get. That's actually how they measure a second. A second actually has nothing to do with the Earth around the sun. It has to do with how fast the electrons revolve around the element of cesium.
So cesium is SECIUM.
I think it's CESIUM. Yeah.
Yes, CESIUM. I thought it was two S's. I was totally wrong. So CESIUM.
Yeah.
That is very interesting.
Yep. I think it's
I'm going to pop that into the trivia part of my memory.
Go ahead and when you get a chance, check out those APIs, and I'd be really fascinated to see what magic you can play with some of the vector files. If you got any global ones or earthquake data, you can play with that. My favorite is looking at some of the Kepler.gl data or mashups. If you're familiar with that, Jeff. So those are like really cool, beautiful visualizations. People like the just beautify maps in general. So those are really cool there. So
yeah.
Cool. Courtney, any last plugs from you?
Just if anyone wants to see whatever, anything about St. Louis Geospatial or St. Louis soccer, I tweet at Court Sloger, Sloger. And would encourage anybody, including you, Jeff, to come visit in St. Louis for GeoInt 2021 and come check it out.
Awesome. Well, thank you both for coming on the show again tonight. We went a little bit long, but I'm glad you're all stuck with it this long, especially the younger fans out there that show up on the show. It's a
very late night for him, yeah.
Yeah. And thank you for those who tuned in tonight. And I know we'll get a few folks watching throughout the week on the recorded version of this. So I'm Adam Simmons with Project Geospatial, here with guests Jeffrey Pearson and Courtney Miller. So signing off, and we'll talk to you.